All right, here are the parametric equations of that curve we were looking at in the last video, and we're going to find the equation of the tangent line to this curve when t is equal to 0. All right, so down in the red box in the corner, I've reminded us of our formula for the derivative of a parametrically defined curve. Let's remember how to find the equation of a tangent line, right? So in algebra, you learned this formula for finding the equation of a line. All right, so we have x1 and y1 that we need to plug in. And then we also need to be able to plug in the slope. And we know that the slope, because this is a tangent line, is going to be defined by the derivative. So I've got it in red to match our derivative box. Let's talk about the easy stuff, x1, y1. X1, y1 are just going to be the points, the coordinates of the point at the curve where t is equal to 0. So we're just going to plug in x1 is just going to be what I get when I plug in t equals 0. So I'm going to be overly deliberate here when I plug in 0. Okay, so that's just a whole lot of 0 plus 5, right? So x1 is going to be 5. That's the x coordinate at the point of tangency. And then y1, we're just going to plug in 0 here. So 0 squared minus 2 times 0. That's just a bunch of 0. All right, so x is equal to 5. Y is equal to 0. All right, so that's going to be our point of tangency. Now we just need to find the slope. The slope is what we get when we plug in our numbers to the derivative. So let's find that derivative, our dy dx. And our formula said this was equal to dy dt over dx dt. All right, so that top part of the fraction just says take the derivative of the y equation with respect to t. So I'm looking at the y equation now. Take the derivative with respect to t. This is an easy polynomial derivative. That's just going to be 2t minus 2. The bottom of that fraction says go over to x now. Look at the x equation. Dx dt is just going to be the derivative of x with respect to t. So that's going to be 3t squared minus, let's see, derivative of 5t squared is going to be 10t. Derivative of 3t is 3, and derivative of 5 is just going to be 0. All right, so that's the formula for the slope. I don't care about the formula, I don't care about the slope anywhere else except for at t equals 0, right? So we're going to plug in t equals 0. So sometimes we use this vertical bar, kind of looks like an integral bar, and we say t equals 0. That means the next thing I'm going to do is plug in a 0. All right, so I get 2 times 0 minus 2, and then 3 times 0 squared minus 10 times 0 plus 3. And it's a whole lot of 0 except for a negative 2 up top and a positive 3 on bottom. All right, and that's my slope that I have over here on the left. So that m is going to be equal to negative 2/3. All right, so the rest of this is just plug and chug. Okay, so I'm going to do y minus 0 equals negative 2/3 for m, x minus x1, which was 5. Okay, so all I've got left is y on the left. And then I'm going to distribute this negative 2/3. Okay, so negative 2/3 x. Negative 2/3 times a positive, sorry, negative 2/3 times a negative 5 is going to be a positive. Remember, 5 is really 5 over 1. So this is going to be a positive. Multiplying on top is going to give me 10 and 3 on bottom. I think I kind of got squished in there. All right. So I get negative 2/3 x plus 10/3. And that's the equation of my tangent line. And that's not going to be satisfying until I look at it on Desmos and make sure it actually looks like a tangent line. So let's go do that. All right, so we're back in Desmos and I've got my parametric curve showing, and we're going to graph our tangent line. Actually, the first thing I want to do is to plot the point. We actually calculated the x1, y1 to be the point, let's see, 5 for x and 0 for y. Okay, so t equals 0 actually lands you at this point over at x equals 5 on the x-axis. All right, and then let's see, what was our equation? We had y equals negative 2/3 x, and then it was plus 10/3. All right, and thankfully, it looks like that exactly gives us a tangent line at the point 5 comma 0. So it works, great. Let's go do another example. All right, same exact process, we've just thrown in a little bit of trig this time. All right, so remember that we are going to use our equation of the line, y minus y1 equals m times x minus x1. All right, we need to plug in the x1, y1. Again, that's just going to be the x coordinate and the y coordinate at the specified t value, which in our case is pi over 3. All right, so x1, we're going to plug in t equals pi over 3 minus sine pi over 3. And then we're going to do the same thing to find y1. We're going to find the cosine of pi over 3. All right, so however you're doing your trig these days, pull out your unit circle, however you want to work it, x1. That pi over 3 is just a pi over 3. That just stays at pi over 3. Sine of pi over 3 is equal to the square root of 3 over 2. All right, so your x coordinate is not pretty. Pi over 3 minus root 3 over 2, just whatever. It's just a number. We'll work with it. Cosine of pi over 3 is much happier number. That's just 1/2. All right, so we're going to plug in over here. We're going to have y minus 1/2. And then we're going to have a slope to put in here somewhere. And then we'll have x minus, just subtract pi over 3. And then I'm subtracting both parts. So imagine you're subtracting pi over 3, and then you're going to subtract a negative root 3 over 2. So that's actually going to turn into plus root 3 over 2. All right, and we need to be able to put this slope in here, whatever we're going to find from the red box for our dy dx. So let's find that next. All right, so our dy dx, our derivative is the derivative with respect to t over the derivative of x with respect to t. All right, so dy dt, we're going to focus in on the y equation. That's cosine. All right, so derivative of cosine is negative sine. And then on the bottom, we do dx dt. So we're focusing in now on the x equation. Derivative of x with respect to t. Derivative of t is just 1. And let's see, derivative of sine is cosine, but we were subtracting. So derivative is positive cosine, but it was a negative in the x formula. All right, so there's our derivative. And again, we don't care about that slope except when t is equal to pi over 3. So now we need to plug in t equals pi over 3 here. All right, this should be fun. Let's see, so negative sine pi over 3 on top. And then 1 minus cosine pi over 3. Thankfully, we've already evaluated these, right? So we've got a negative sign. Sine of pi over 3 was root 3 over 2. On the bottom, I've got 1 minus cosine pi over 3, which was 1/2. Again, those are just values from the unit circle. So I've got negative root 3 over 2. 1 minus 1/2, that one's not too bad, 1/2, right? And that's just a dividing fraction. So we're going to flip the one on the bottom and multiply, or keep, change, flip, however you learn to do that. So I've got negative root 3 over 2 times, flip the 1/2 over, 2 over 1. And blessedly, this ends up being not too terrible, right? I get negative root 3. All right, and that's the number that needs to go in the blank over here, negative root 3. All right, so I'm going to distribute, this should be fun. I'm going to distribute that root 3, that negative root 3 through that set of parentheses. So I've got y minus 1/2 equals negative root 3x. Distribute the negative root 3 to negative pi over 3. We're like using all of the math symbols in one problem. So I've got root 3 times pi. I'm actually going to write that as pi root 3 on top, and then that 3 on the bottom. And then the last one, so here's where I'm taking that negative root 3 and multiplying times root 3 over 2. Just kind of in my scratch work over here, that would be negative root 3 times root 3 over 2. Root 3 times root 3, that's root 3 squared. That's just a 3. So you're going to get negative 3/2 there when you distribute. Okay. So actually, that should be a negative, what did I say? 3 over 2? There we go. All right, so let's get this scratch work away. And let's see, I'm going to just add that 1/2 to both sides. So I'm going to add 1/2, and I'm going to add 1/2. And mercifully, they already have a common denominator. So on the left, I've got a y. Then on the right, I've got negative root 3 times x. Got that weird pi root 3 over 3. And then negative 3 over 2 plus 1 over 2 is going to be negative 2 over 2, or negative 1. And that is not easy on the eyes, but that's the equation of our tangent line. So let's go graph this equation on Desmos, this parametric curve, and see if this line actually looks like it's tangent somewhere. All right, so I've already typed these things in because they were so complex. We've got our parametrically defined curve, which ends up giving us this sort of scallop shaped graph. And there was the point, pi over 3 minus root 3 over 2 was our x coordinate and 1/2 was our y coordinate, which was our first clue that this was going to be a little bit more difficult. And so far, so good. That appears to be a point on the graph. And then let's turn on this equation that we found, and hopefully it's going to be tangent right through that blue point. And good, good, good. Okay, so that worked. We found our tangent line. All right, so this is a good thing on your homework that you can always go graph these in Desmos, and it makes you feel better that you did all your calculations correctly. All right, so we'll move on with the calculus of polar curves whenever we meet together in class.